Hi, my name is Sydney Cumby, and this is my Physics 2212, Lab 4, bar magnets. So, within this presentation, I will explain an introduction and purpose, as long as equations that I used within this experiment. The actual experiment itself, my computations and codes, my final results, additional questions that are given within the lab, and a conclusion of everything that I learned and the final stuff within the lab. So I'll start with the purpose. The purpose of this lab is to determine the magnetic moment of a bar magnet by using a cell phone magnometer app that our TAs instructed us to download. And then we will write a code that accurately visualizes the bar magnet's magnetic field. So next is my introduction. So a few assumptions. Assume that the x-axis is defined by the magnometer as the distance along the width of the phone, and then the y is going to be the distance along the height, and the z-axis will point out of the screen. Our system in this experiment is the phone, and then our surroundings is the bar magnet and everything else surrounding. So a few initial conditions. We must have the phone pointing north. If you don't, then as explained later on in this lab, it'll mess up your results. So the final results I got are that the dipole moment will be calculated with code, and then the magnometer is far away from the magnet and measures near zero magnetic field in the x direction. So a few equations I used. In the top left is what I used to create or calculate magnetic field. It's Boyd-Sarp's law. And then the two on the right and the bottom left I used to calculate the field versus the distance for the bar magnet, which is needed to find N, K, and U. So next I will go to the experiment setup, and within this experiment setup, we first had to align the app with Earth's magnetic north-south axis. That was when we orientated our phone north. Then, to do that, you had to rotate the phone until the x component was 0. Then we had to find the multimeter sensor in the phone. So using this, we did it with sticks, like meter sticks, bar magnets, and tape, putting tape on the phone at each piece when the x was at its maximum and the y was at its minimum. And we just constantly rotated the phone until we found the intersection point where the sensor was. So now I have my calculations. To find the constant N and K, I use a line of best fit of ln bx versus the ln r graph. Then, using that, I found my slope and my intercept to get my K value. Then to calculate the magnetic moment, I know that R is equal to 0.1034. I found that using the equations shown in the beginning of this experiment. And then some similarities and differences of my results. The experimental value of B field was 8.67 e minus 7, or like e to the negative 7, comma 3.1 e to the negative 6, 4.38 e to the negative 5, and that was negative, while the calculated one was 6.9 e to the negative 6, 2.0 e to the negative 5, and 0. So for my code, I wrote code for the constants, how to create the magnetic at the origin, or the magnet at the origin, function for magnetic field, how to visualize the magnetic field on the axis and perpendicular to the axis. I created arrows on the axis and created arrows perpendicular to the axis. And finally, visualizing the magnetic field on the 45-degree off axis. Here is the result of my experiment or code. Now I'll answer the what ifs and additional questions. So for the first one, if I had orientated my experiment to be north, then the Earth's magnetic field would have affected the x and y components of the magnometer, altering my results. For the second one, since there are two magnets, there would be a double magnetic field, so we can expect the measurements to double. Finally, for my discussion and conclusions, a few possible sources of error could have been any electrical equipment around the magnetic field readings and not lining up the magnometer exactly north before starting. Conclusions: our phones have magnometer chips in them which can detect magnetic field in a bar, and the actual and experimental B values differ within experiment.